Number 83 is a problem that we didn't do great on as a class, and I would guess that the issue most of us had here was kind of trying to interpret what exactly was the connection between the function that they gave us, which was an acceleration function, and then what it was they were asking for. What's the value of t where the particle's velocity is decreasing most rapidly? So it's a question about the rate of change of your velocity function, and we need to remember here that acceleration, right here guys, the definition of acceleration is change in velocity over change in time. So whatever our acceleration is at a particular moment, that tells us the rate of change of velocity. So all I think we have to do here, guys, is to find a minimum value of a of t. Looks like it's on the interval here from 0 to 8. And I think that minimum value, or I should say the t value at which that minimum occurs, is going to get us the answer that we're looking for. So I would handle this one, I believe, just by doing a graph. I think would be the easiest way to do it, and finding out where this thing kind of bottoms out and hits a minimum value here on this interval from 0 to 8. So I'm going to go to my calculator here, and I'm going to go to a graph page. And let's see, I know I had some stuff from a previous problem, so I think I'm going to reset everything here. We're going to delete all, and yes, that's fine. And while I'm at it, let me go back to my normal viewing window here. Actually, I tell you what, I'll come back to that later because I might need to change that. Okay, our function right here was, come on, calculator, do a thing. There we go. All right, I believe we had a t minus 8 times the sine of t. Now, when we're graphing, we'll have to use an x right here. So that t minus 8 becomes an x minus 8, and then multiplied by the sine of x. Let me make sure I got that right. Yeah. And we're on the interval here just from 0 to 8. So let me go ahead and graph this thing. My window's all messed up. So let me go here and window and zoom, and I'll just do settings. And for an x minimum, we really just need 0 here, and for an x maximum, we're going to need to see 8. For my y min and y max, this is a guess. I don't know how low to go with this, so let me kind of leave it where it is right now and hit OK. Okay, good. I can see the bottom of this curve right here. And it looks like, oh boy, kind of hard to tell, from 0 to 8, this minimum occurs maybe somewhere around a value of 1. So this trough here, guys, this low value on the curve is the spot where acceleration is the lowest, and that tells us that velocity is decreasing the fastest at that spot right there. Now, if I was in a real hurry, I would take a look at these 4 answers right here and say that my answer is probably B for number 83, because that looks like the x value at which this minimum occurs. But if I got a little bit more time, let's do this right. Let's use our calculator. Let's go to Analyze Graph, and let's find the minimum on this curve between that lower bound and that upper bound. And here we go, guys. 1.420 is, in fact, where that minimum occurs. So our answer here is going to be B for problem number 83. That's the t value at which the minimum value of acceleration occurs.